Hello, students. I'm Professor Benavides, and let's go over Chapter 4, Part 2. Now, Chapter 4 is entitled Working with Lists. In Part 2, we're going to drill down on numeric lists. And before I forget to plug it, I do like the cheat sheets that the author has, so let me go ahead and bring it up. And as usual, it opens up on my other monitor, so let me just go ahead and bring it in here. This is what we're going to talk about. And we got two whopping chapters on lists, Chapter 3 and Chapter 4. And we're going to speak specifically about the range function, some simple statistics, and that's really about it. The rest of it is things that we've already covered or things that we're going to cover in the Part 3 of Chapter 4 that I'm going to cover in a separate video. Okay, so making numeric lists. The way your author does this is he uses the range function or introduces the range function to create a list. So basically the range function causes Python to start counting at the first value that you give it, and it stops when it reaches the second value you provide. Stops means it doesn't include it, right? This has sometimes resulted in off by one errors or programmers experiencing off by one errors. So it's definitely something you want to double check if you're getting an off by one error. You can also pass a range, only one argument instead of two. Of course, you know, later on we're going to see that it takes three. So if you just pass it one, it will start the sequence of numbers at 0. You know, so before we go ahead and take a look at that example specifically, well, yeah, let's go ahead and let's look at it now. Our first example here, let me go ahead and run it. The first, on line 5, I have a for loop, and I see my range function. I'm giving it 2 arguments, so it's going to start at 1. It's going to go all the way up to 4, all the way up to 5, but not including 5. That means it's going to print 1 through 4. In this second example, we only provided 1 argument. So it's going to start at 0 and go all the way up to 5. So it'll be 0, 1, 2, 3, 4, 5, 6 elements in total. Okay. So the range function generates a series of numbers. It starts at the first argument and stops, I should say, before it reaches the second argument. So we can use the range to make a list of numbers. If you want to make a list of numbers, you can convert the results of a range directly into a list using the list function. So when you wrap list around a call to the range function, the output will be a list of numbers. So let's go ahead and take a look at that. Here, what happens first, let me go ahead and run this, is the range function happens first because it is enclosed in the list function, right? So the output of this becomes an argument to the list function. And that is how we create our list of numbers and then print them on line 5. One thing that does drive a lot of my students batty is the fact that Sublime, somehow or another, on line 4, you'll notice that there's a capital L on here. It looks like a capital L, but it's not a capital L. It's a lowercase L. So there's some other little freaky things like this. I remember, was it? Yeah, it was back in Chapter 2 where we were talking about the L strip. Well, the L in L strip looks like a number 1. And that can throw a few people. It's just a font thing. Now we can change fonts. There's different ways in which we can do that. We're not going to cover that right now. You know, because we just want to concentrate on the coding. And I did want to alert you to the fact that it looks like a capital L, but it is in fact a lowercase l. Sorry, I didn't invent this stuff. Okay. So we're using range to make a list of numbers. Now what's happening here is that range does its thing and it feeds that to list. Now what list does is it gets these numbers and it creates a list based upon these numbers. Okay, that's what it does. If you pass a third argument to range, Python uses that value as a step size when generating numbers. So the three arguments are start, stop, step. He doesn't really show you any syntax stuff, but if you want syntax, you can just go online. W3 Schools is a great place to look at the syntax for the different Python coding structures. So let's look at our next example here. In this next example, we see the three arguments for range. So range can take 1, 2, or 3 arguments. Okay. So if you use the third argument, it'll provide a step size. So here we see, let me go ahead and run this. Here we see that it starts on 2, goes all the way up to 11, doesn't include 11, and it's going in increments of 2. So what does this do for us? This allows us to create a list of numbers between the range of 2 and 10. And that the result of this range function, see, our function returns a value. Remember, a function performs an action and returns a value. So that value is returned to list. List gets that and creates a list called even numbers. And then I print even numbers on line 4. Okay. Now, just remember, it stops on the second value. It doesn't go up to, it does not include, it's not inclusive. That's why it goes from 2 to 10. That's something that a lot of people got to get used to. So you can create almost any set of numbers that you want using the range function. For example, consider how you might list the first 10 square numbers, that is the square of each integer from 1 to 10. In Python, 2 asterisks represent exponents. So let's go ahead and take a look at how that can be done. So here, let me go ahead and run away in case I forget. On line 4, I create an empty list because I'm going to populate it. And then in line 7, I go ahead and use a loop. And I'm going to loop through each value in the range. And what I'm going to do is I'm going to get that value, and I'm going to get the exponent of that value. Okay? And I'm going to then store it in a variable, a temporary variable on line 8 called square. I am then going to pass square to the append method of squares. Okay? So the append method, we learned that in the previous chapter. That is how we then add that number to our list. And then I simply print out the list of squares, right? Okay. So let's look at another example. We could get the same output if we omit the temporary variable. Now, a lot of times advanced users like to make things simpler, and simpler is not necessarily the best thing for the beginner. So what we're going to look at in the next examples here is how we can go ahead and get rid of this step, this line of code on line 8, and reduce this from 3 lines to 2 lines. Let's go ahead and take a look at that. So basically, we're talking about this temporary variable on here. So what happens here is that we're going to write the code more concisely. We're going to omit the temporary variable called square and append each new value directly to the list. So I'm getting every value in this range, and I'm getting the exponent of it, right? and I'm appending it directly to the list called squares, and then I'm printing it. So you can see I get the exact same output as I did before, but I have one less line of code. So the point is this: sometimes using temporary variables makes your code easier to read. Other times it makes the code unnecessarily long. Who will think that it's unnecessarily long? Advanced users. So personally, I don't have any problem with the first version. So it's pretty much up to you. As far as simple statistics with lists, let's go ahead and take a look at this. If we have a list, and this is just a list of numbers, we didn't use the range function to generate them. We just simply have a simple list of numbers, and we're going to call this list digits. If I run this, we find that the min is 0, the max is 9, and the sum is 45. So basically what happens here is that we've got these built-in functions called min, max, and sum. And we can apply these functions to the list. And when we apply these functions, they return a value, and that value is then an argument to the print function, which then prints it. Now, this wasn't the way that your author did this in the book. Your author went over here to the command line and entered into the Python interpreter and created the simple list there. I'm only going to go up to 4 because 4 is enough, right? So I've got, my list. So if I want to just say min and pass it digits, I get 1. Okay. If I go ahead and look at this, if I just press the up arrow key, I get min again, and I'm just going to call it max, right? I get 4. And then if I want, I can go ahead and do the sum. And the sum of those is what? 10. Okay. So that's the way he did his little demo. Remember, a lot of advanced users love to go into the Python terminal. It allows them to circulate through all the different ways of learning something really, really, really fast. The other thing that you can do, guys, if you'd like, you can go into idle. And if you've got it so that idle opens up without configuring it, it should open up to the shell, and you could end up doing the same thing here. The only benefit here is that you get a little more color. You can, in fact, you can actually, configure the color a little bit. Let me just do the same thing. So digits get square brackets 1, 2, 3, and 4. Close it. And then we'll just get min of digits. So I get 1. So see how I get a little bit of color on here? You don't get that in the Python interpreter. It's all one color. Of course, I changed it to green, but green is the color of all the text. I can change the background color as well, but that's about it. You only get like 2 colors. So with this one here, elements of code get different colors, and colors are really great when you're learning a language and learning the elements of the language. Now, you can't use the up and down arrow here, but what you can do is just select and do a Control-C, and then come over here and then do a Control-V if you want to reissue a particular command or change it or edit it or something like that. Okay. So that's simple statistics. Now, he talks about something called list comprehensions. So this approach described earlier for generating list squares consists of using 3 or 4 lines of code. A list comprehension allows you to generate this same list in just 1 line of code. Okay? So list comprehension combines the for loop and the creation of the new elements in one line and automatically appends each to a new element. Let's take a small look at that in this little demo here. Now up here at the top, I show you the long way of doing this. Actually, I'm only using 2 lines here. I could have used 3. And then I'm using the list comprehension. So let me just go ahead and go over the syntax of this briefly with you. So the syntax is, you start off with the name of your list, and then the equal sign, right? And then the square brackets, fine. Then the first thing we put in here is the expression. See, here's our expression right here. This is the expression. It evaluates to something. We have value exponent 2, right? After the expression, we have our for loop. Okay? That is the general syntax of a list comprehension. So yeah, I'm getting, I don't have to do line 4, line 5, or line 6. Actually, I could have had another line here. Remember that temporary variable on? I created a temporary variable called square, and then I passed. So we got rid of the temporary variable on this example here, and I'm just making an assignment directly to the squares list. So I can make this even more concise, and advanced users just love this. So an advanced user would call this simple. So when an advanced user tells you something is simple, you're in trouble right away. But this is an excellent example of something that people refer to as Pythonic. It is Pythonic because Python programmers like to code in a simplistic way. The simplistic way does not necessarily mean that it's simple. You have to be pretty much an advanced programmer to write your code in this simple way. So here you have it. You have a longer way of doing it from line 4 to 6, and a shorter way all in one line on line 10 for your viewing pleasure. Okay. So let's go ahead and take a look at the try it yourself. So let's look at 4.3. So we're going back in time, and we're looking at a very simple example. Control B. And all this does is it uses a for loop to print the numbers from 1 to 20 inclusive. So great, we see the range function takes 1 to 21. Remember, because it doesn't include 21. Hopefully you're getting used to that. So it goes from 1 to 20, right? So line 6, we say for number in numbers. Remember, we covered in chapter 3 that lists should be plural. So that when we use this temporary variable here, it should be singular. You don't want to be getting cutesy and coming up with some crazy names for things. You don't want to go uppercase or use anything other than lowercase. Remember the conventions, the PEP 8. If this is going to be 2 words, it's going to be lowercase underscore and then another lowercase word. Okay. So this simply prints the numbers 1 through 20. They're generated with the range function. The result of this is passed to the list function, which converts it into a list called numbers. Then I go ahead and use a for loop to traverse every element in this list and print it with the print method on line 7. Let's look at our next example on here. This is example 4.5, and we're going to sum a million, right? So make a list of the numbers from 1 to 1 million, and then use the min and max to make your list actually start at 1 and end at a million. Also use the sum to function to see how quickly Python can add a million numbers. Well, yeah, it does it. It does it pretty fast. Let's just go ahead and run it. So it did it in like 0.2 seconds, right? So let's take a quick look over here on line 4. Here's the range function, and it's going from 1 to 1,000,001. Notice how we're using the underscore here as a separator so that we can visually see and understand that this is 1 million. This is an excellent little tactic to use for very, very large numbers. And then we go ahead and use the min function on our list, the max function on the list, and then the sum function on the list. Pretty much, you know, these little do-it-yourselfers are kind of like a way of rehashing the concepts that we learned in the chapter. And I'm simply using the print function to go ahead and show it on the screen. I could have created a nice little fancy formatted string, but I just wanted to be Pythonic. Okay, all right, but anyway, let's go ahead and go on to the next one on here. The next one on here, make a list of the multiples of 3 from 3 to 30. Use a for loop to print the numbers in your list. We're going to call our list 3s. So notice how we've got 3 arguments here. It's going to start at 3. It's going to go all the way to 30. And it's going to go have a step of 3. Okay, go ahead and run this. And so it's going 3, 6, 9, 12, right? As you would expect, going all the way to 30. Right? And that's because we use this loop to print every element in this list. Okay, so let's go on to the next one. The 4, 9, and 4, 8 kind of go together. And yeah, you know where we're going. We're going to show you the long way of doing things. And then we're going to show you how to do it as a list comprehension. Now they call it the long way. I call it the easy way. I mean, it's strange how, you know, we can have different interpretations of easy. But let's go ahead and take a look at this. On line 4, I have an empty list called cubes. So cubes, it's do-it-yourself, 4.8. And a number raised to the 3rd power is called a cube. Okay? For example, the cube of 2 is written as 2 asterisk asterisk 3 in Python. Make a list of the first 10 cubes, that is, cubes of each integer from 1 through 10. Use a for loop to print out the value of each cube. So line 4, I start off with the list. It's empty. Then on line 6, I create a list of the first 10 cubes. So I'm going from 1. I'm going all the way up to, but not including 10. I mean, not including 11, right? And what I'm doing here is I'm creating a temporary variable called cube. And notice how that's the singular version of cubes. I didn't invent a crazy name here. Okay. So then I'm getting, you know, number, because it also is, you know, a temporary variable that and it makes sense because I'm dealing with numbers, right? So I have number and I'm cubing it. So the result of this expression, this is an expression. An expression is something that evaluates and returns something. So number asterisk asterisk 3, the result of this will be assigned to cube on line 7, because this is an assignment statement. Remember, whatever's on the right gets assigned to what's on the left. So then cube is appended to cubes with the append method. Okay, and notice I didn't say function, I said method, right? So the append method appends that number to the list. After I loop through all of these from 1 through 10, I go ahead and generate my numbers. Let me go ahead and run that. And it's quite a lot of little numbers here cubed. You'd have to get a calculator to see if that's right, because I certainly won't be able to tell you. So, I mean, you know, yeah, 1 and 8. That's about as far as I can go, maybe 27 on here. Okay, so let's see how this can be turned into a list comprehension. Okay. On this next one, we see that I don't create an empty list. I do it all on one line, all on one line. So what happens first? First, I put in the expression. Then I put in my loop. It's kind of like reversed a little bit. And let's go back over here. Notice how we have our loop first, and then we have the expression. I mean, that's just something that I noticed. So that when we get over here, we do the expression first, and then the loop. And then we don't create the list as an empty list beforehand. We do it all on one line. And this is the way advanced users love to code. That's why it's referred to as, Pythonic. And there's all kinds of special kinds of words like that and ideas. It's a very special community of programmers. So that is the end of this second session or second part of chapter 4, working with lists. It's part 2, numeric lists. Let's just go ahead and compare that. Remember, I told you I like to always go and look at the cheat sheet before and after I cover something. And let's see if I can go ahead and recognize what we just went over. Let's see, where is it? The range function. Yeah, we covered the range function pretty good. So we used the range function to work with a, to work with a set of numbers efficiently. So it starts at 0 by default, and you can just keep on reading about this, and it shows you how you can iterate through the range with the for loop, and simple statistics with the min function, max function. It doesn't seem like there's a little summary of list comprehensions. Oh yeah, here it is. List comprehensions are in the middle here. So you can use a loop to generate the list based upon a range of numbers or on another list. It just goes on to talk about that. So we'll cover the rest of these topics in the third part of chapter 4, where we'll also talk about styling your code, which is really important. He's embraced the PEP 8, and I've been trying to impress upon you that you just there's a particular way of creating your variables and your lists and the way we name things, and it's really important that we pay attention to that as we program. Other than that, Professor Benavides, over and out.